What I needed, though, was hard crack.
Not surprised. It's time for some more NileRed. Specifically, turning plastic styrofoam waste into candy. Can't say I recommend doing that with nuclear waste. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge.
Over the years, I've made a lot of videos where I turn completely inedible things into food, and some of my favorite transformations have been things like turning plastic gloves into hot sauce and paint thinner into cherry soda.
Wow.
Something that I've been always wanting to do,
I don't think I knew about the paint thinner one.
though, is to try and turn styrofoam into cinnamon candy, and just like all of my other transformations, this might not immediately make sense.
I mean, the idea of converting waste into something else is nothing outside the scope of nuclear engineering. Take spent nuclear fuel. I mean, it contains valuable components, such as uranium and plutonium, that can be reused. What's interesting is, in most fuel types, you don't start with plutonium, but you get plutonium over the course of a fuel cycle. Because uranium-238 becomes uranium-239, undergoes a couple of betas, becomes plutonium-239, which is also fissile and can be used. Just like I would assume he's going to break down the polystyrene and the styrofoam to be used in some way to be used to make cinnamon candy. The spent fuel will be dissolved in nitric acid, actually, to separate the uranium and plutonium from the fission products within the spent fuel so it can be reused. It's a shame that it's not really done anymore, but it's not always the most economical choice, and there's overblown concerns of proliferation.
However, at least in theory, it should be possible, and this is because styrofoam is made from a plastic known as polystyrene, which in turn is built from a bunch of smaller molecules known just as styrene.
Sure.
On its own, styrene
Makes sense. Poly, multiple styrenes.
is kind of an interesting chemical, but what I think is more interesting is that it looks surprisingly similar to this, which is the naturally occurring chemical that gives cinnamon its smell and flavor. The only difference...
Yeah, all you got to do is attach that on there. It's funny how you can look at things that are very similar, kind of like just that I mentioned difference between uranium-238, which is not fissile, and plutonium-239, which is you give it another neutron and you have two neutrons decide to turn into protons.
The difference is that this cinnamon flavor, known as cinnamaldehyde, has this small little part at the top, but other than that, it's pretty much the same. And it's really weird that such a small change can make it go from being a potential carcinogen to tasting like cinnamon. But either way, the moment that I saw this, I felt that it...
Not to say cinnamon is a carcinogen, but yeah, it's funny what a relatively small change does.
Had to be possible to turn one into the other, and the plan that I came up with in my head was relatively simple. All I had to do was get some styrofoam and somehow break it down back into styrene, use some chemistry to turn it into cinnamon.
Use some chemistry. I love that. Reminds me in certain math classes where you start off with what the starting equation is, and then you try to get to something, and then you write on there, and then magic happens, and then a miracle happens, or something like that. I love it, though. You're beginning with the end in mind. It's an important principle in project management.
Cinnamon flavor, and then use that to make some hopefully tasty cinnamon candy.
On their little hearts.
The only unfortunate part was that doing this in real life was going to be a lot more difficult, and I wasn't even sure if it would work. But as usual, I figured there was only one way to find out.
Probably involves some really expensive single-use equipment from China or something, knowing how these videos usually go.
But anyway, to get started, the first thing that I was going to need was some styrofoam, and just by chance, when I was cleaning things up earlier in the week, I had found this entire bag of cups. I actually have no idea where I got them from, or why I even had them, but I definitely wasn't using them for anything else.
When you bought the lab, it just came with it or something? I don't know.
And I felt that they were kind of perfect for this project. So
Cool.
I decided to just go ahead and use them, and the first thing that I was going to have to do was get all the air out of them. This is because styrofoam in general is actually mostly air, And even though this cup looked and felt solid, it was at least around 95% empty
Super
space.
porous.
All of this empty
Why so
space
light?
actually makes it a pretty good insulator, and it makes it work really well to keep things hot or cold. But in my case, this extra volume was a problem.
Yeah.
So I was going to have to get rid of it, which was thankfully pretty easy. And all I had to do was get this large dish, and to add a bunch of acetone nail was going to have to get rid of it, which was thankfully pretty easy. And all I had to do was get this large dish, and to add a bunch of acetone nail polish remover. I then went and got the cup, and I carefully lowered it in, and almost immediately, I could see that it was releasing a bunch of small air bubbles. It was also making a really nice...
So this is analogous to the reprocessing example. This would be the equivalent of taking your used fuel into a nitric acid mixture in order to... So this is similar to the step of dissolving the used fuel in nitric acid in order to separate it into uranium, plutonium, and the other fission products. This process is known as Purex.
Fizzing noise, which I thought was kind of satisfying, and as I kept pushing on it, it was slowly getting eaten by the acetone. Then, over the next 15 seconds, the entire cup gradually disappeared, and eventually, I was left with this little puddle of goo. At this point, what I had was also clearly nothing like the styrofoam that I'd started with, but what I think is interesting is that no reaction had actually taken place. Chemically, it was still exactly the same thing as styrofoam, which is made from a plastic called polystyrene, and the only difference was that it was no longer puffed up with air. This is because the acetone is able to partially dissolve the polystyrene, which softens it, and it allows all of the air to escape. This then left me with a bunch of plastic that was taking up at least 95% less space, and what I had to do next was just add the rest of the cups. So I continued adding them one by one,
disassembling it.
But I quickly realized that doing it like this was going to take a really long time, and I instead started throwing in a bunch at once. What was nice was that they still seemed to melt away just as quickly as the single cup, and again, I couldn't help but find this process oddly satisfying.
Yeah, just a matter of maximizing the surface area interaction with the acetone. But yeah, I find this satisfying too.
However, something that I should mention is that even though there was no reaction going on here, this was still letting off a bunch of acetone vapor, and having an open solvent like this is a big fire hazard.
I was going to say, because it's not just interacting with the styrofoam, you're interacting with the air. So fire hazard, inhalation hazard.
On top of that, the goo itself is absolutely horrible when it lights on fire because it'll stick to everything, and something very similar to this is
goo.
used to make modern-day napalm. But with that being said, when the last cups eventually disappeared,
because napalm kind of sticks.
I was left with this huge blob of polystyrene, which, as I just mentioned, was super flammable and really sticky. However, this was just because it was completely soaked with acetone, and to turn it into something that I could actually work with, I was gonna have to dry it out. So I quickly poured off as much of the acetone as I could, and then I dumped out all of this goo onto a large baking tray. I also did my best to spread it out as evenly as possible, and again, I feel like it's important to mention that this was kind of a huge fire hazard.
So if this were done in a lab at a nuclear plant, you would want to post the fire hazard for this experiment, ensure no open flames are in the vicinity. We'd even want to use grounded equipment just to prevent an accidental spark, because acetone has a very low flash point of minus 20 Celsius. And you'll want to do this in a well-ventilated fume hood. You want to make sure the fire extinguisher you have is Class B. That's one suitable for flammable liquids and vapors. And of course, use the appropriate PPE. Can't say I've ever seen someone try this at a nuclear plant, but always important to consider the safety procedures.
But either way, all I had to do now was just let it sit there and wait for the acetone to evaporate, and after a few days, this was what I was left with.
I was going to say the fume hood and exhaust fans could help with that.
On the outside, it looked like it was nice and dry, but what was kind of annoying was that on the inside, it was still pretty soft and gooey. This told me that if I ever wanted it to fully dry, I was going to have to start breaking it apart, and this was thankfully pretty easy. It also had a really interesting texture, and in my opinion,
Yeah.
it kind of felt like pulling apart a fresh quesadilla.
Sure. The gooey, cheesy goo.
When I eventually felt that I'd split it apart enough, I let it dry for a few hours, and then I came back to it and split it apart again. I then repeated this process a
Like
few
that he's
more
just doing it
times
by hand.
and left it overnight to fully dry, and in the morning, I was left with some nice and dry chunks of polystyrene. The only problem was that they were still way too big, and what I really wanted was some nice powder, so I just dumped them all into a blender.
There you go.
I then turned it on to the max setting, and they all immediately started getting torn apart. It was also kind of working, even better than I thought it would, and after just a couple of minutes, it already looked like it was a decent powder.
Wow, okay.
The only part that I really didn't like was that I started seeing some acetone vapor condensing on the sides of the blender.
Yeah.
I really thought that all of the acetone was gone, but clearly there was still some left over,
Don't want to spark in your blender so it'll blow up.
and this was both annoying and potentially really dangerous. This is because if there was enough left, it could cause it all to gum up again, and in theory, it could also ignite and potentially cause the blender to explode. So I made the decision to pretty much immediately stop it, and what I had to do next was take a closer look at it. I had to be sure that stopping it early didn't leave a bunch of huge chunks in it, and it was actually way better than I expected. It was also pretty much exactly what I was hoping for,
Cool.
and it was just a nice pile of powdered polystyrene,
Pile of powdered polystyrene. Say that 10 times fast.
and it definitely took up way less volume than all of the cups that I started with. Most importantly, though, it was now in a form that was actually usable, and after over a week of waiting, it was finally time to try and turn this plastic into some hopefully amazing cinnamon
It's crazy how long the holding patterns are, like waiting a week and each step of cutting it up and letting it dry.
flavor. So I decided to just immediately start, and the first thing that I was going to have to do was break down all of this polystyrene back into just styrene. Based on a little research, this also didn't seem too difficult, and I was able to find a few people on YouTube who had already done it, and I even found this really useful article
One of them said
that
benzene.
outlined the process in detail. This article also suggested using a catalyst called magnesium oxide, which I thought was kind of interesting, and I really wanted to try it out. So I decided to just go for it, and the first step was to get a flask and to carefully
check this
pour
out.
in all of my crispy polystyrene powder. Then on top of this, I added 65 grams of magnesium oxide, which, as I said before, was
Looks very similar, but it is not.
supposed to act as a catalyst.
Look at it.
Theoretically, it
Go
probably
out.
would have been a good idea to mix it in, but I didn't really think that it was necessary, and honestly, I was feeling a bit lazy. So instead, I just quickly cleaned up the flask and got rid of any loose powder, and I started putting together the rest of the setup. To do this, I first added a short path condenser to the middle neck, and I sealed the other two with some stoppers because I wasn't going to need them. Then, at the other end of the condenser, I attached a vacuum adapter and a flask, and with all of this in place, the setup was very close to being done.
Cool.
The only other thing that I had to do was put a heating mantle under the reaction flask and to attach some water lines to the condenser, and at this point, it was good to go. So, when I felt that I was ready, I just cranked up the heating, and I waited for it to get nice and hot. For a while, though, it really didn't seem like very much was happening, and over the next 15 minutes, all it did was just shrink a bit.
In reprocessing the nuclear fuel, catalysts are also used, specifically organic reagents, to facilitate the isotope separation. And again, since toxic fumes are involved, need to ensure it's well ventilated. And of course, in the aspect of the spent fuel, radiation exposure, radiological briefings are going to be utilized for obvious reasons. What type of shielding they're going to use, what steps are going to be done remotely so you're nowhere near the spent fuel, because spent fuel has the highest level of radioactivity compared to any other type of nuclear waste. And there's also, since it's spent fuel, And technically material that is used to start reactions, you're going to have a criticality hazard briefing to ensure that you do not inadvertently form a critical mass that starts a reaction. There have been numerous criticality accidents throughout the history of nuclear power, most infamous being the Demon Core. Now, unlikely you're going to get a critical mass during reprocessing. In fact, calculations are done to make sure that you physically can't put that much nuclear material together, and these checks are verified by a separate engineer, and you do final checks once you get the materials together, just to be absolutely sure.
When I saw this, I started getting slightly worried that I'd potentially ruined things by not properly mixing the catalyst, but then almost right at that moment, I was greeted with a nice little puff of smoke. This was then followed by a lot more smoke, which started filling the entire setup, and I felt that this was a good sign. This because it showed me that something was for sure happening, and the polystyrene was clearly starting to break down.
Cool.
As far as I know, this was mostly happening just because of the heat alone, which was causing the long polymer chains of the plastic to slowly split apart. At the same time, though, all of the magnesium oxide catalyst was supposed to be helping with this process and making it go a lot faster. The only unfortunate part was that right now, it didn't seem like any of this smoke was actually styrene, and I think it was mostly just smaller fragments of the polystyrene.
Well, whether it's styrene or polystyrene, good thing he's got it set up in a fume hood, at least I'm assuming. I know he's used it in a lot of his other videos.
To fully break it apart and to get single molecules of styrene, I was gonna have to keep heating it and to let it cook a bit more. So I just kept going, and as it slowly got closer to 400 Celsius, or 752 Fahrenheit, it actually started making some liquid, which was really nice to see. This because, in theory, this was supposed to be mostly styrene, and now, I basically just had to wait. So I just let it sit there, and over the next few hours, I slowly collected some murky yellow liquid. Eventually, though, it completely stopped coming over, and when I looked over at the other flask, I saw that there was pretty much nothing left. It was now just a bunch of black crust, which was probably mostly the catalyst, along with a small amount of tar. This was a very good sign that pretty much all of it had been converted, and at this point, the reaction was definitely done. So I turned off all the heating, and I went back over to the other flask that was filled with my beautiful yellow liquid. As I mentioned before, this was supposed to be mostly styrene, and I was pretty happy with how much I got, but considering that pure styrene is clear and colorless, this was obviously full of a bunch of other trash. I was definitely going to have to clean it up a bit, and to get started with this, I quickly poured it all into a separatory funnel. This then caused it to separate into two layers, where the bottom one, as far as I know, was mostly just water, and I'm not entirely sure where it came from. It really didn't matter though, because it was all just trash, and to get rid of it, I just quickly drained it away. This left me with some yellow liquid, which was still pretty much just as dirty as it was before, and to continue cleaning it, I poured it all into a beaker. Then into this, I started adding a bunch of white powder called sodium sulfate, and I was hoping that it would pull out any water that might have still been there. I was also hoping that this would get rid of all of the cloudiness, and when I came back to it about 20 minutes later, it was nice and crystal clear, which I was really happy to see. The only unfortunate part was that the sodium sulfate hadn't just magically taken away the yellow color, and there was obviously still a bunch of garbage in here. So I was still going to have to clean it up a bit more, and to do this, I started by pouring it into a funnel that had some cotton at the bottom. This would block out any sodium sulfate.
I love how clean and pristine all of his equipment look, at least the way he's doing it, by showing each step of the process rather than having it all cluttered on there at once. It's definitely good. It kind of comes from a how-to video, assuming you have all this stuff at home. Can't say that I do.
That I might have accidentally transferred over, and everything was getting filtered directly into a fresh round bottom flask. Then, when it all eventually passed through, I got rid of the funnel, and I quickly put together pretty much the exact same setup as before.
Okay.
The only difference this time was that I included a thermometer, which in this case was gonna be extremely important. With everything in place, I then cranked up the heating, and within just several minutes, it had already started boiling. There was also some vapor that was quickly traveling up the column, and when it eventually made it to the condenser, I started collecting some colorless and crystal clear drops of liquid. This was really good to see because it showed me that the distillation was definitely getting rid of that nasty yellow stuff, except what was sad was that this wasn't actually styrene.
Oh,
It was just some random side product, and I knew this because the temperature on the thermometer was only around 40 C, and this told me that the vapor that was coming over was only barely warm. It wasn't even close to being hot enough to be styrene, which would be well over 100 C, and I was just gonna have to wait for the temperature to slowly rise. So I just sat there watching it gradually collect more and more clear liquid, and when it eventually got to around 100 C, it started to look a bit milky. It was also around this point that I started getting more and more nervous that the temperature just wouldn't stop increasing and that somehow there wasn't actually any styrene here, and I probably worry like this during most of my distillations. However, eventually, it thankfully ended up stopping.
In general, there's a lot of times that you can't really tell what it is, I've seen. Of course, a lot of this seems kind of off the cuff. It's not there's a standard procedure that tells you what other conditions to look out for. I mean, you can eyeball the temperature, but if milky's good, if that weird yellow stuff was good, it's interesting. Now, in nuclear engineering and operating nuclear power plants, a lot of times questionable results are written up and included using the condition reporting process and like included as addenda, sometimes visually sometimes with pictures or things that tie to specific incidents, just so it's like, hey, this happened and this was good or this wasn't so good and here's how you fix it. That's one easy advantage I had working in a nuclear power plant is there were a lot of people there with 30 plus years of experience when I first started that were able to tell me, hey, this is good or this isn't. But if you're doing something like this, where I don't know if this has been done or if it has, it hasn't been shared as well, then let's just say there's lots of opportunities will be observed to improve.
Stopping at exactly 142 C.
And it has nothing to do with how good of a chemist NileRed is. It's just learning curves.
Or 288 Fahrenheit, which was extremely close to the boiling point of styrene. This told me that now, everything that was coming over was probably some nearly pure styrene, so I quickly got rid of this flask that was filled with junk, and I swapped it out for a fresh one. At the bottom of this flask, I also included a very small amount of something called 4-tert-butyl catechol, which would help stabilize the styrene and prevent it from spontaneously turning back into polystyrene. But anyway, at this point, I just had to do a bit more waiting, and over the next 30 minutes, all of the styrene slowly distilled over.
That's interesting, is a lot of chemical reactions can be reversible, which is why you put something like that in there. Whereas radioactive decay, for instance, it's not going to go back. Because you're going from unstable to more stable to stable, at least eventually. There might be a lot. There's often several intermediate steps between something decaying into something that is stable, or I could just say more stable, like uranium-238, while radioactive, is actually fairly stable because its half-life is 5 billion years, compared to something like iodine-131 that's on the order of days. So stable is relative, but the point being, you're not going to have thorium-234 decide to absorb a helium nucleus and turn back into uranium-238. That's not a thing.
During this time, I also carefully watched the temperature, and when it started to rise again, I knew that the distillation was done. So I turned off the heating and I carefully removed the flask, and what I had now was just a bunch of nice and clear liquid, and it was kind of weird to think that this used to be a bunch of styrofoam cups. With that being said, though, based on just the smell and the boiling point alone, I was 99.9% sure that this was styrene.
And neglecting some losses, that's going to be probably the majority of how much those cups weighed, because a lot of it was air, which frankly didn't weigh very much, because he meant 95. When he said 95%, he meant 95% by volume, not by mass. So that amount of liquid is is definitely the majority of that, because it's not like much was lost in that process. Be interesting to see, though.
But to be 100% sure, I was going to have to do a couple tests. These tests were also relatively quick to do, and I just had to run a small amount of it through these two little instruments that I have, where the first one does something called FTIR, and the second does something called HNMR. I then got these results, which may or may not mean absolutely nothing to you, but together they told...
These are types of spectroscopy, which can be used to identify what something is. FTIR, Fourier transform infrared. So we're using infrared radiation here. And you're identifying, I guess, the functional groups of a molecule at this point, since we're not dealing with something that's radioactive. I've used spectroscopy quite a bit, but mainly with radioisotopes. So you'd look at the peaks of each individual. You look at the emission peaks of, say, gammas or alphas or betas or neutrons or what have you. But here it looks like you're looking at molecules. HNMR, I'm not sure about the H. HNMR is hydrogen nuclear magnetic resonance. Basically, you look at hydrogen within a molecule and observe their absorption patterns when exposed to a magnetic field. So FTIR, functional groups such as a hydroxyl group, and HNMR, you're looking at hydrogen. It's my understanding anyway.
That this was for sure styrene, and that it was relatively pure. So now, knowing this, I was able to move on to the next step. And what I think is interesting is that even though all of this styrene just smelled like plastic and kind of gave me a headache, it was actually pretty close to being cinnamon flavor. In theory, I was really only one step away, and the only thing that I was missing was this small section here. This meant that I was, of course, going to have to somehow add it, and while it didn't look too complicated, it was going to be the most difficult part.
Yeah, you just draw a couple of lines on each one, put an H and put an O. I've heard that involved, like, synthesizing atoms or whatever, or even in various aspects of nanotechnology, and it's just, you don't realize what that actually means and what it actually does when people make those kind of comments. It's just funny.
With a simple Google search, though, I quickly found this on Wikipedia, which claimed that it was possible using something called the Vilsmeier-Hawk reaction.
Cool.
Finding an actual procedure, unfortunately, wasn't as easy.
Of course.
But after searching for a while, I was thankfully able to find one in this paper, and it was even better than what I was hoping for. So I
Nice. Finding a procedure for something is good.
Decided to just go ahead and try it out. And to get started, I went and got a fresh flask, and I added 70 mils of a solvent called dimethylformamide, or DMF for short. Then after that, I added a stir plate and a large dish filled with ice, and I dropped in a stir bar. I also turned on the stirring and added a thermometer, as well as an addition funnel and a stopper. With all of this in place, I then had to wait for the DMF to cool down, and in the meantime, I went and got another chemical called phosphorus oxychloride. This is honestly kind of a horrible chemical, and it's both really corrosive and kind of toxic, but it was exactly what I needed to make my cinnamon flavor, and I added about 37 grams to the addition funnel. I then carefully sealed the top and went to take a look at the thermometer.
I like how quick you just poured that in there after all the safety label.
And it was extremely hard to see, but it showed that the DMF was now less than 10 degrees Celsius. This meant that it was good to go, and when I felt that I was ready, I carefully opened the addition funnel and I unleashed the phosphorus oxychloride. I then did my best to adjust it so that it would get added at a slow but steady rate, and what I had to do now was just closely watch the temperature to make sure that it never went above 20°C. This is because if this happened, the reaction could potentially get out of control, and while it wouldn't just explode or something, it could cause the entire thing to boil over.
That's one important thing to keep into consideration, that reaction speeds tend to go up with temperature. That's one there's an accident analysis condition used for This is an important factor to keep in mind when looking at how fuel cladding in nuclear fuels responds during accidents. At the plant I worked at, the fuel was clad in a zirconium alloy and was very safe, very contained in terms of both the heat and the radiation. But during a really bad loss of coolant accident, there's the potential if the fuel overheats that the zircaloy interacting with the water, the zircaloy could react with the water if it gets above 2200 degrees Fahrenheit, which is, again, an extreme accident scenario, but has the potential to release hydrogen gas in explosive concentrations, which is one of the reasons why we have hydrogen recombiners that prevent that in turn. And those use heaters to essentially recombine the hydrogen gas and oxygen gas that just exists in the atmosphere. Because in this scenario, basically the reactor coolant system would need to be destroyed in this type of accident for this sort of thing to even take place. And it essentially turns it back into water.
What I did think was kind of interesting, though, was that it didn't really look like very much was happening, and it almost looked like I was just adding water to more water. However, in theory, the nasty phosphorus...
That happens all the time in nuclear power plants. Your liquid rad waste is discharged, and by the time it's discharged into the environment, it's treated, and you wait for it to decay away, and yeah, you're discharging water into more water. In some cases, water that's cleaner than what's already in the environment.
Oxychloride was supposed to be reacting and combining with the DMF to make a new molecule, which is known as the Vilsmeier reagent. Okay. This was supposed to be the main active ingredient in this reaction, and in just a few minutes, it's gonna make a lot more sense why I'm making it. With that being said, when it was eventually all added, I got rid of the addition funnel, and what I had to do next was just let it stir for a bit to make sure that it had all reacted. While I was waiting, though, it was the perfect time to go and get all of the styrene that I
literally thought he was just going to grab a cold one.
Just made, and to measure out the amount that I needed. When I was first planning this reaction, I was really tempted to just risk it all and use everything, but at the same time, I knew that was a horrible idea. This is because there have been way too many times where a reaction has just totally failed on me, and considering that I'd never done this one before, I didn't really have the confidence. So in the end, I decided to go with only 27.5 mils of the styrene, which was about 1/3 of what I had, and this would give me a couple more attempts if this ended up being a complete failure.
Always good to have a backup plan.
With that being said, at this point, the Vilsmeier reagent was definitely ready, and the next step was to slowly add all of the styrene. I started by pouring in just a small amount, and at first, it really didn't look like much was happening. It really seemed like it was just going to be another step where it would feel like I was just mixing water with water, except eventually, it actually started changing color. This told me that there was definitely some sort of reaction going on, and in theory, the styrene should have been attacking the Vilsmeier reagent and forming a bond with it. This would then lead to the formation of this new intermediate, which was basically a combination of both molecules, and now it was starting to look a bit closer to cinnamaldehyde. What I also thought was interesting was that this intermediate technically had a second form that existed at the same time.
I like that he shows these little diagrams on the side so you can track what's going on.
And this will be important later on. But anyway, what I had to do next was make sure that everything fully reacted here, and to do that, I was gonna have to heat it up. So I just quickly pulled out all of the ice, and I replaced it with some water, and I added another thermometer. I then cranked up the heating, and as it warmed up, the color of it gradually shifted to orange, and then to something that kind of looked like some tasty cranberry juice. It was, of course, still just a bunch of toxic and carcinogenic chemicals, though, and despite how good it looked, it would have been an absolutely horrible idea to taste it. But anyway, it eventually got to
waiting for him to say, but I did it anyway, because why not?
55°C, and according to the procedure, this was when it was supposed to suddenly start heating up. It also said that it could potentially heat up so much that it needed to be cooled, but for whatever reason, that didn't seem to happen. It did look like it was slowly getting darker though, which told me that more of it was definitely reacting. So I gave it about half an hour to make sure that I didn't cause some sort of disaster, and when it seemed safe, I cranked the temperature even higher. It then continued to slowly heat up, and over the next 45 minutes, it got even darker.
Oh,
In
wow.
fact, by the time that it got to
Gonna try to
around
make red wine?
75°C, it was nearly black, and at this point, the reaction was probably really close to being done. Just to be absolutely sure that everything had reacted, though, I had to let it sit like this for another hour.
Mm.
When I came back to it, I was kind of
Reach
surprised to
equilibrium.
see that it had gotten even darker, and now I was ready to move on to the final step of the reaction. So I just quickly took apart this entire setup and poured everything into a beaker that was surrounded by ice. This is because what I had to do now was pretty much the opposite of the previous step, and I had to cool it as much as possible. I was going to have to get it as close to 0°C as I could, and while I was waiting, I also
Interesting.
had to mix together another solution.
Heating and cooling.
So I went and got a beaker, and I added 340 mils of water, followed by 133.5 grams of something called anhydrous sodium acetate. I then started mixing it around to get it to dissolve, and after only a few minutes, it had pretty much all disappeared. With this ready, I was able to go back and check on the other stuff, which
orange.
during this time had partially solidified. When I saw this,
Ow.
I was a bit concerned that this might be an issue, but at the same time, I figured that it was probably fine. It was also around 0°C, which was exactly what I wanted, and I decided to just go with it. So I started by adding a very small amount of the sodium acetate solution, and almost immediately, it thankfully started loosening up. I was very happy to
It's
see
impressive.
this, but at the same time, it was also starting to heat up quite a
Yeah.
bit, and I had to make sure that it stayed cool. What was supposed to be happening here, though, was pretty exciting, and all of the water that was in the solution I was adding should have been attacking the intermediate from before. More specifically, it should have been attacking this
Now it's
form of the
red.
intermediate, causing a portion of it to get kicked off, and leading to the formation of the final cinnamaldehyde. Also, as a side note, all of the sodium acetate
Red's
that was
often
in the
associated
solution
with
I was
sodium
adding
flavor.
wasn't just doing nothing, and it was there to act as something called a buffer, which would help keep the pH constant, and this was very important for this reaction. When I was eventually done adding it, though, I let it stir for a bit longer, and when it looked like the color stopped changing, I pulled it out of the ice bath. I then carefully placed it into a hot water bath that I had preheated to 75°C, because again, I apparently had to heat it up. However, this was thankfully going to be the last time that I had to do this,
A lot of
and it was
cheating
just to
and
be
Hitler.
absolutely sure that it thankfully going to be the last time that I had to do this, and it was just to be absolutely sure that it all reacted. This way, I'd be able to get as much of the cinnamaldehyde as possible. I mean, assuming that the reaction was actually working. When I came back to it about 15 minutes later, it looked pretty much the same, and the only difference was that it seemed to be a bit clearer. At this point, though, it should have finally been done, and the only thing left to do was to put it in the fridge and to let it cool down. I then left it overnight, and in the morning, when I opened the door, I was hit almost immediately with the really nice smell of cinnamon.
There you have it. So going back to our analogy for reprocessing, the uranium that you have left can be re-enriched or fabricated back into new fuel rods. The plutonium that you have can actually be mixed with uranium to create what's known as a mixed oxide fuel. So you essentially have a hybrid of uranium and plutonium used in a reactor. Now what's interesting is plutonium is quite a bit more reactive than uranium. So this can be placed, so this will make an interesting Scrabble board type game of where you need to position your fuel optimally to get your triple word score or a stable heat and radiation profile within your core. But it kind of looks like that. And you could even, if you can separate it, take some of the radioisotopes such as iodine-131 or technetium-99, use those in medical imaging or cancer treatment and diagnosis. Depends a bit on your burnup. But anyway.
At the same time, I was also really excited and kind of surprised by what I saw, because on the surface, there was now what looked like a thick layer of oil. It was very possible that this was almost entirely cinnamaldehyde, and this was a really good sign. The only
Cinnamon
unfortunate
oil.
part was that all of this potential cinnamaldehyde looked like it was black, and it was clearly full of a bunch of nasty junk. So even though it was kind of tempting,
And again, back to the analogy, you have to separate it kind of like separating the good stuff from nuclear waste. Because you have nice flavoring mixed in with poison.
tasting it like this would have been an absolutely horrible idea, and I was definitely going to have to clean it up. On the bright side, this was supposed to be a relatively straightforward process, and the first step was to pour it all into a separatory funnel.
Sure.
On top of this, I then dumped in 100 mils of a solvent called diethyl ether, which was immediately able to mix with the oily layer on top. I then sealed it with a stopper and carefully took it off the stand, and I started shaking it around.
Whoa.
I was doing this to try and force the diethyl ether and the water to mix, which should help the ether pull out any cinnamaldehyde that might have been stuck in the water. When I eventually felt that I'd shaken it enough, I put it back on the stand, and over the next few minutes, it separated into 2 layers again. This time, though, the bottom water layer was a lot clearer, which was good, and it told me that the ether had probably pulled out some cinnamaldehyde. With this in mind, I then carefully drained away all of this red water, and I took the ether oil mixture that was left in the funnel, and I poured it into a beaker.
Okay.
Then after that, I put all of the water back into the separatory funnel, and I added some ether, and I repeated the exact same extraction process 4 more times.
Just to get all you can.
I was doing this just to make sure that I got out absolutely everything,
Right.
and when I was done, I was left with a beaker full of nice red liquid. Most of this was just all the ether that I had added, and only a small amount was the oil that I actually wanted.
Yeah, because you saw how thin that layer was, so this is all the ether.
But what was important was that it was already a lot cleaner than what I had started with. The only unfortunate part was that there was for sure still a bunch of trash in it that I was going to have to get rid of, and to get started with this, I had to pour it all back into a separatory funnel. I then dumped in 100 mils of regular water, which almost immediately turned yellow, and this told me that it was definitely pulling out a bunch of crap. In particular, though, I was really hoping that it was removing any DMF, which was in the original reaction mixture, and that was for sure picked up by the ether. I also wanted to be absolutely certain that all of this DMF was gone before moving on, and the easiest way to do this was to just wash it with a huge amount of water. So I decided to repeat this same washing 5 more times, which should have been more than enough, and by the end, the water was almost colorless. This meant that it probably wasn't pulling out much of anything anymore, and I quickly drained away all of the water. I then took all of my slightly less red liquid, and I transferred it all to a flask, and I set it up for a distillation. I then cranked up the heating, and I was doing this to get rid of all of the ether, and only a few minutes later, it was already boiling. After that, it only took about 30 seconds to start collecting some crystal clear ether.
Now, how many times is it going to have to do this distillation? Because this is also an iterative process just to make sure you get what you can get out of it.
Ether in the beaker, and now I just had to wait for it all to pass over. This wasn't going to take very long, though, and only about 20 minutes later, it was pretty much done. What was left in the flask was now a super dark and goopy liquid, and again, it didn't really seem like it, but this was theoretically cleaner than the oil I started with.
Did it smell like cinnamon?
To get pure cinnamaldehyde, though, there was just a bit more cleaning to do, and I felt that the easiest way to do this was to just do another distillation. So I just carefully transferred all of it to a much smaller flask, and I quickly put together pretty much the same setup. The only slight difference this time was that instead of collecting everything in a beaker or a single flask, I was going to have to use 3 flasks, and I also had to attach a vacuum line. All of this extra stuff.
I mean, I understand about the vacuum line, but
kind of made it look a lot more complicated, but it was still more or less the same thing, and it'll all make sense in a bit. In any case, when I felt that I was ready, I turned on my vacuum pump, and I carefully pulled all of the air out of the setup. I also cranked up the heating, and only a few minutes later, I saw that it was already starting to boil. The vapor was also starting to climb out of the flask, and it wasn't long before I started collecting a nice and colorless liquid. This was very exciting, and I was very happy to see that it wasn't a nasty red color, except just like last time, I knew for sure that it was unfortunately just trash. This is because when I looked at the thermometer, I saw that it was only around 30°C, which was still way too low for it to be cinnamaldehyde. The temperature was continuously rising though, which was good, and I just had to patiently wait until it got to the boiling point of cinnamaldehyde. The only tricky part was that because this was all being done under a vacuum, the boiling point of cinnamaldehyde was going to be much lower than its normal temperature of 248°C.
That's actually one of the hazards when dealing with low-pressure fluids is the tendency to flash to steam and cause hydraulic transients. It's also why if you go the other direction, highly pressurized, such as 2250 psi in a nuclear power plant, you can have liquid water upwards of 600 degrees Fahrenheit.
Or 478 Fahrenheit. Instead, it was probably going to be around 100°C or 212 Fahrenheit, which was a value that I got using this online calculator, but it was very hard or even impossible to perfectly predict. This made me a bit worried that I would have trouble differentiating it from the junk that I had to separate it from, but there really wasn't too much that I could do about this. It was also absolutely not.
This is a form of just compensating for pressure. Just like when you're dealing with atmospheric pressure, there's an expression in the nuclear industry called "don't get G'd," and basically the difference between absolute pressure and gauge pressure. Gauge pressure, you have to add the 14.7 psi in order to find out what the absolute pressure is. Comes up a lot when you're reading pressures off of a gauge, say in a higher pressure system, such as the suction of the main turbine, which can be on the order of 750 psi, compared to the condenser. That's psi-G, by the way, so you got to add 14.7. Compared to the condenser, which there you're at 29 inches of mercury vacuum, which is well below 1 psi absolute. You really don't want to be off, especially when you're dealing with something out of vacuum.
Not an option to do it without a vacuum and in the presence of air, because this would cause a lot of the cinnamaldehyde to just get oxidized and destroyed.
Yeah.
So all I could do was just continue patiently waiting and watching the temperature, and to hope that it magically stopped at 100°C. However, long story short, that didn't happen, and it ended up going right past it and stopping at 125°C, which was a lot higher than I expected. As I just mentioned, though, the boiling point under a vacuum is always hard to predict, and it was very possible that cinnamaldehyde was now coming over. What also made me think this was that when I looked at it much closer, it seemed to be faintly yellow, just like pure cinnamaldehyde, and I decided to just commit to it. So I carefully twisted the end of the setup, which allowed me to swap the flask without releasing the vacuum, and now I was fully separating this fraction.
Okay.
I then continued.
That's the reason for the triple, to get some and then okay. Just more convenient, basically, rather than having to unscrew and screw another one back on.
Continued collecting this yellow oil and carefully watching the temperature, and over the next hour, the flask slowly filled up. At some point, though, the temperature suddenly dropped, which told me that some higher boiling point stuff was going to start coming over, and when I looked back at the original flask, it looked like all that was left was some red junk. At this point, the distillation was done, and I was almost certain that what I had now was some nice and relatively clean cinnamaldehyde.
Okay.
What concerned me was that it was definitely way more yellow than pure cinnamaldehyde should be, and the idea of tasting it like this was honestly making me uncomfortable. So just to be safe and to put my mind at ease, I was unfortunately going to have to clean it up a bit more, and to do this, I
Get
quickly
another.
put together this fresh and clean distillation
Okay.
setup. I then cranked up the heating, and it really
This is going to be like Russian nesting dolls associated with smaller and smaller sets of distillation equipment all the way down.
wasn't long before some drops started coming over, and this time I decided to collect a decent amount before swapping the flasks. This would just really make sure that I got rid of any impurities, and when I felt that I'd sacrificed enough, I switched it to the second one. What I was collecting now should have been extremely pure cinnamaldehyde, and what was very nice to see was that it was definitely a lot less yellow.
Okay.
I then just kept going and waiting for the temperature to suddenly drop, and when I saw this happen, I quickly switched it to the third flask. I also turned off the heating as well as the vacuum pump, and at this point, I was finally done. After weeks of work, I now had the beautiful pale yellow oil that I was hoping for, and I carefully started transferring it all to a vial. As I did this, I was also hit almost immediately with the super nice and sweet smell of cinnamon,
Nice.
and by now, I was pretty much 100% sure that this was pure cinnamaldehyde.
Cool.
However, if I was gonna taste it, I was of course gonna have to be absolutely sure, so I went ahead and ran some tests on it. Like the styrene, I did both an FTIR and an HNMR, and this was what they gave me. Again, it might not mean anything, but together,
pretty distinctive peaks there.
They showed me that this was for sure cinnamaldehyde and that it was quite pure, and I was very happy to see this.
Yeah, those are some really pretty peaks.
This is because now, after all of this work, I could finally taste it, and I wouldn't have to worry too much about it instantly killing me. I should say, though, that there was still a chance that it contained something horrible that didn't show up on the NMR, and in general, it's not a good idea to taste any homemade chemicals. But either way, I just pulled out a small amount of it, and I sucked it into my mouth.
The well-calibrated tongue of a chemist.
Well. Okay. Definitely cinnamon. But it kind of tastes good. It doesn't burn nearly as much as I thought pure cinnamon oil would.
Basically the cinnamon challenge, NileRed style.
And it's also kind of sweet. Every other flavor I've had just tastes horrible or weirdly enough burns my mouth, even when it's supposed to just taste like grape or something.
I remember the grape one, yeah.
This is supposed to burn, and it doesn't even burn that much. It's kind of interesting.
Does it not burn enough?
So I for sure had some nice and tasty cinnamon oil, but more importantly, it was now finally time to try and make some candy with it. Specifically, though, I really wanted to make little cinnamon hearts, which have always been one of my favorite candies, and I wanted them to look as close as possible to the classic ones that I grew up with. The only tricky part was that I quickly found out
I can't say I've ever been a fan of these. Little too spicy and tongue burny, actually, for me.
That to make them like this, it was a lot harder than I thought, and it was also going to be extremely expensive. However, long story short, I ended up...
Here we go. This always seems to be a staple of NileRed. Unique, expensive equipment.
Spending an obscene amount of money, and a couple of months later, I was the proud owner of this customized candy making machine. More accurately, though, it was mostly just the rollers that were customized, and there were little hearts carved out into each of them. They were also the exact size and shape that I wanted them to be, and right now it might not be super obvious how this is used to make candy, but it'll make a lot more sense in a few minutes.
I mean, it's pretty obvious how it's going to press and get those molds.
With that being said, now that I had the machine, I was finally able to get started, and the first step was to get a pot with a thermometer attached to it. Then into this, I poured in half a cup of water, followed by 2 cups of regular table sugar.
Okay, now we're getting into the cooking portion of this, which, knowing NileRed's other videos, the chemistry stuff is often bang on, or at least I guess you should say but the cooking stuff is where the funny stuff happens.
And a 1/4 cup of corn syrup. This was apparently all that was needed to make hard candy, and from what I could tell, the only difference between most recipes was the proportion of each ingredient. The specific recipe that I was using, though, was from this video made by the channel Flavor Lab, and I just
don't claim
felt
to
that
be
it
a
looked
chef.
good. But either way, with everything added, I quickly mixed it around, and when I eventually felt that it looked nice and even, I turned on the cooktop and cranked up the heating. I then just had to leave it and wait for it to warm up, and to carefully watch the thermometer. This is because as it got hotter and as the water in it slowly boiled away, the temperature was supposed to slowly increase. According to the
Generally
Flavor
happens when
Lab
you
video,
boil.
this would gradually bring the candy through several stages, where the first one was referred to as softball. What I needed, though, was hard crack,
Not surprised.
which would occur between 290 and
Only time I've ever done something like this was making pralines, or pralines as some people say. And there I remember only targeting softball. More of a softball guy. I tend to stay away from hard crack.
310 Fahrenheit, and this would give me candy that was hard like a lollipop.
Sure.
So I just let it go, and over the next 20 minutes, the temperature slowly rose, and eventually, it got to the 290 mark. I decided to let it go a bit further,
Here
though,
we go.
until about 300 Fahrenheit, and the moment that I saw this happen, I turned off the heating and got rid of the thermometer. At this point, the base candy should have been ready, and it was time to give it some flavor. So I went and got
Here it
all of my
comes.
precious cinnamon oil, and I carefully pulled out 3.7 mils, which ended up being most of it.
Yeah.
I then quickly shot it into the still
There it
super hot
goes.
sugar, and I thought that it was kind of interesting to see it just sit on top and basically do nothing. However, this was only because the boiling point of cinnamaldehyde was way higher than 300 Fahrenheit,
Sure.
and with most other flavors, shooting it in like this would probably be a bad idea. Regardless of that, I was now super close to being done, and there was just one last, but extremely important ingredient to add. This was, of course, some potentially carcinogenic red dye, which was absolutely essential to make proper cinnamon candy, and I felt that several drops would be enough.
Like that's potentially more risky than the cinnamaldehyde, that he went through all of those risky, carcinogenic, transitional steps to get you there.
I then quickly
But remember, we started off with Styrofoam, and again, using the fuel reprocessing analogy, you can get more fuel, different fuel, as well as medical isotopes.
mixed it around, and in less than a minute, it had a nice red color, but I wanted it to be even stronger, so I dumped in a whole bunch more. After this, I was
Dude.
actually able to get the exact red color that I was looking for, and at this point, things were looking really good. I was starting to feel a little nervous, though, because what I had to do next was the actual hard part, and I was kind of worried that I would completely screw it up. However, I chose to instead just
Is that a
not think
hair?
about it, and I
No.
pulled the sugar off the cooktop, and I quickly poured it onto some silicone. I then started moving it around while it was cooling down, and eventually, it was supposed to turn into something that was kind of like bread dough. Long story short, though, that
Is it?
didn't happen, and I did completely screw it up, and instead of getting something that was soft and malleable,
A big
I got something that was filled
old piece of chewing gum. Yeah.
with a bunch of hard chunks. The moment that I saw this, I honestly started to panic, and I really started worrying that I had just lost the majority of my cinnamon oil.
Does it taste like cinnamon?
Totally failed. It's simple as that. I failed. You know? Pack up our bags. That's it. That's our candy. This is it. That's the cinnamon candy.
Dude, you got your expensive equipment, though.
What made things even worse was that I couldn't find anything about this online or how to fix it, and it really seemed like I was just going to have to restart. At the same time, though, I felt that there had to be a way to remelt it without burning it or completely destroying it, and I figured that it was at least worth a try.
Gonna stick it in the microwave.
I also felt that I had to at least make an attempt to not just lose the majority of my cinnamon oil, and in my mind, the best first step was to very carefully break apart all the sugar.
Very carefully.
No! This gave me some nice little pieces, which I was able to put all back into the pot.
Oh,
And then I
man.
put this back onto the cooktop.
So the nuclear equivalent of this would be getting everything back to your high-quality nuclear material after mining, enriching, and purifying everything, only to screw up the sintering of your uranium dioxide pellets, such as introduction of impurities or just getting the temperature and pressure wrong, and then you have a bunch of cracks in it, and you can't use it. That's unfortunate.
On top of this, I also shot in a random amount of water, as well as a completely arbitrary amount of corn syrup, and I cranked up the heating.
I also remember distinctively in the procedure on proper power plant operator communication over the radio, it explicitly mentioned like shooting something, like shooting acid, say you're batching boric acid to make for reactivity control of your reactor. And it didn't like saying that. It doesn't like slang terms. And just so people can always be clear on the radio, which has great intentions. It's important that everyone knows what's going on when you're doing critical operations. But if you're doing something low risk, and you have a bunch of bored guys on night shift, people are absolutely going to say stuff like that.
I then just waited for it to melt, and what I was hoping for here was that all of the extra water would help prevent the sugar from burning, and that the extra corn syrup would make it take longer to harden. The only thing that kind of concerned me was that heating it again would potentially cause it to caramelize, and by the time that it got to 300 Fahrenheit, it was looking a lot frothier than before. It also looked like it was turning brown, which really scared me, but it seemed like it was mostly just because the food...
Now, brown strikes me as more cinnamony, even though a lot of the candy's red, hence the red dye.
Coloring was breaking down. So I just blasted in some extra red color and mixed it around, and very quickly...
You make a little smiley face.
All of the froth disappeared, and it actually looked really good.
I like how imprecise he is with the dye.
I wasn't going to let it cool down at all.
And really everything with this seems fairly coarse and imprecise compared to the extra precautions used during the chemical processes. Kind of just shows you where his strengths lie. It's funny.
Almost immediately pulled it off the cooktop and started pouring it out. Compared to before, it was definitely way more liquidy, which I felt was good. And I did my best to constantly move it around. While I was doing this, I was also still really worried that I would end up just getting a bunch of solid chunks again, but that thankfully didn't happen. Instead, over the next several minutes, it just slowly got thicker, and eventually, I had pretty much exactly what I wanted. It was just a blob of gooey sugar, which felt almost shockingly similar to hot bread dough, and I was happy to see that my recovery attempt had actually worked. There was unfortunately almost no time to celebrate this, though, because I still had to turn all of this sugar goo into some nice little cinnamon hearts before it cooled down.
Use your expensive machine from China.
Time to use my machine. From what I saw online, it also seemed super straightforward, and I basically just had to throw it into the rollers.
It was actually bigger than I realized.
So that was exactly what I did, and for the most part, it seemed to be going pretty well, and I was super happy to see that it was forming some beautiful little hearts. The only weird part was that it was a lot more difficult to turn than I thought, and I think this was because the sugar that I was putting in had cooled down a bit too much.
This needs to be like anchored to the ground.
I also might have been just going too slow, which was causing it to solidify, and I was only able to squish half of the sugar before it became way too hard.
Okay.
Percussive maintenance.
So I ended up having to basically just give up trying, and it was honestly kind of impressive how badly I had screwed up this entire process. Despite that, though, it wasn't like it was just a complete...
You know what I like the most about this guy is he admits when he screws up, and it's all... Because it's all learning, it's all stuff he's doing off the cuff. I mean, no one expects perfection when they're watching something like this, but I like that he shares his journey throughout. And kind of definitely keeps people watching, keeps me watching.
Complete failure, because I was still able to get a bunch of little hearts, and they were actually super nice. To get them apart, I also just had to apply a bit of force, and they all easily crumbled, which I thought was really satisfying.
Oh yeah. ASMR noises.
After that, I then spent a couple minutes breaking apart the hearts that were still stuck together, and at this point, I was extremely close to being done. In theory, there was just one last step, which was to coat the candies with more sugar and to give them that classic look that I originally wanted. I had actually even bought an entire machine to help me do this, but after seeing how nice they were without a coating, I decided to keep them this way. There was just something that I really liked.
Have those jagged sugar cinnamon edges in your mouth when you eat it.
About them like this, and now, after months of working on this project, I was finally done.
Finally done.
Awesome.
And I think there's only one thing left to do. After all this work, I can see, was it all worth it for this?
You put your heart into it.
We'll see.
That was terrible.
Okay. It tastes... I mean...
It tastes...
I don't know why I'm surprised. It tastes exactly like cinnamon candy. It's really good.
Nice.
It has pretty much the exact flavor that I wanted. It's not too much cinnamon, not too little. It's a very nice, mild cinnamon candy. The only thing that I think is, that kind of threw me off, normally they just crunch. But this one, it's a bit more chewy. It's kind of like I just made cinnamon heart Jolly Ranchers, basically.
Okay. Cool.
Oh, that one was crunchy for some reason. And more cinnamony. Okay, I clearly need to refine my candy skills. But overall, I'm honestly kind of amazed at how well they turned out.
I mean, who'd have thought Styrofoam, essentially a waste material at that point, turned something that was disposable into something that people like. Now, granted, he's going to have some interesting scaling operations to contend with, as well as some costs. I'm not sure how many of these he has to make and sell in order to justify the purchase of that, but we'll see. Though the fact that this doesn't appear to be cost-effective is kind of similar reasons why spent fuel isn't reprocessed in the US, as mining fresh uranium is relatively cheap and abundant compared to the cost of reprocessing. And you have to invest in heavy infrastructure, like the comparatively super expensive machine from China that NileRed used, in order to do something like that. Not to mention the proliferation concerns with plutonium, though that one is overblown and shouldn't be, and isn't a legitimate reason, in my opinion. People just see plutonium and it's something they don't understand, and they really don't but they know it's associated with weapons, but they don't understand how just having plutonium does not mean it's easy to make a bomb. I like the quote from Oppenheimer that said, a sandwich is probably more useful to the bad guys because they'll at least have something to eat, where just plutonium, you'd have to go through a ton of steps to get you there. And there's still, even though it's more efficient, reprocessing creates high-level liquid waste, which you don't see at a nuclear plant, typically. Basically, liquid spent fuel as part of the processing. This is kind of analogous to this, how he had made some carcinogenic compounds on the way from going from styrofoam to cinnamon candy, both things you don't think of carcinogens when you think of those two things, other than maybe the red dye. So it's mainly the cost as far as why, at least within the US, they use the once-through cycle, which does bother me from an optimal efficiency standpoint, but I can see why that's the case if the costs just don't justify it.
Okay, so in the end, and despite an almost impressive lack of candy-making skill, I think I can still call this project a success. I mean, I was actually able to turn a bunch of old styrofoam cups into some nice little cinnamon candies, and even though they weren't exactly perfect, I'm still really happy with them. What will also be fun is that in the future, I do plan to revisit this whole candy-making process, and I have at least a few projects that I think are going to be really interesting. However, in the meantime, I'll be taking a little break from candy And I'm gonna be focusing on some more dangerous projects, like turning air into a bomb.
Ooh, I wonder what he means by that. That could mean a lot of things. Well, one, you could just pressurize it. That can create an explosive outcome. But I'm thinking he's going to do something more interesting than that. Possibly nitrogen-based explosives by extracting that from the air. Or he could use oxygen and make fuel-air explosives. Or just simply enrich something that's already combusting with oxygen. Or he could go the whole styropyro route and just make a bunch of high-energy plasma with Tesla coils or lasers or something that at least looks explosive, but I don't know about that one. Well, anyway, we'll see. Thanks again for the recommendation, and thanks so much for watching. I'll see you next time.